already started that, but we were not able to complete. So we are going to continue that. Okay, and after completion of your C bond, we are going to start a topic called as your EDA. Okay, EDA. We will work on that. Okay. So yesterday we saw data visualization. So Seaborn library. So Seaborn library is built on Matplotlib. So we are working on class. We are working on the Titanic dataset. We are working on the Titanic dataset. So let it load. Okay. So we have loaded the Titanic dataset. Okay. So we saw class heat map. Heat map we already seen. Okay. We have seen distribution plot also. Okay. We have seen your count plot also. We have seen bar plot also. Okay, this is your count plot. We have seen joint plot. Joint plot is basically a combination of your like distribution plot plus some other plot, and this some other plot can be like it can be your hex plot also, or regression plot maybe. Okay, or your scatter plot maybe. Okay, your hex or your histogram plot maybe. Okay. So that is a joint plot. Then after this we saw your bar plot. Okay, bar plot we have seen. So we are going to continue after this only, after bar plot. Okay, class. So next is your box plot. Next is box plot. Now, what is box plot, class? Box plot is basically it helps us to analyze two columns. This helps us to analyze two columns, one categorical versus continuous data. Okay, and also one more thing, this plot also helps us to identify outliers. Now, what are outliers, class? What are outliers? Okay, suppose you are working. Let me give you an example. Okay. Suppose we are talking about suppose we're talking about age of a particular student, okay, who is studying in college, okay, in undergraduate college, okay, who is currently doing undergraduation. Okay, so now basically according to the trend, okay, not a trend actually, according to the pattern that we see everywhere. Okay, I'm talking about India right now at least. Okay, so according to the pattern that we see, the age group, the age of the student who is in a college, okay, be it in first year, be it in final year. Okay, so the general age group of a student is usually between your 17 to 21 years of age. 17 to 21, or maybe you can, if you want to include some error, let's say 16 to 22 years of age. Okay, this is the general age of a particular student who is inside a who is in a who is in a college, who is in a college. Now, what happens, class? What happens? Suppose, let's say I'm creating an application. I'm creating an application for any college, okay, where I want to predict. Suppose a new student is going to take admission in the college, and I want to predict the age of that incoming student. Okay, so in that case, what we can do, like we will take some data, okay, of multiple colleges all across India, maybe. Okay, we'll take data of multiple colleges all across the India. Now let's say there is some college, XYZ college, somewhere in India. Okay, and in that college there are some students in the class who are of the age of 25 years. They're pursuing their undergraduate course. Okay, but they are 25 years of age. Okay, now if I'm taking this data to make a machine learn, okay, to teach a machine, if I'm taking this data, okay, and the data is saying that, okay, the student can be of, let's say, 25 years of age. Now think about this, the whole machine learning algorithm, okay, or the whole analysis that you are doing on that particular data will become wrong. Why? Because of some students who are of the age of 25 years of age, or maybe more, okay, who are basically not following the pattern. See, it is completely fine if the student is of 25 years of age, it is completely fine. But suppose if I'm a machine and I'm trying to predict, okay, and somebody tells that a particular student can be of 25 years of age also, So what will I do? I will take 25 years into consideration while predicting, while analyzing. Okay, while whenever I'm working on data, so I can assume that okay, a student can be of 25 years of age, but that is entirely wrong. Here, why? Because the probability of a student of being 25 years of age while in the college is very, 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 very less, not even 1%. Okay, I'm talking about India right now again, and in undergraduate course, any undergraduate course you can take. Okay, being 25 years age, it is very, very less. So now here, this will be called as outlier class. The data points which don't follow a particular pattern, the data points. Okay, let me take out the. Now, are you saying something?
No, sir.
See, let me write down the definition here also. This is the definition. In statistics, an outlier is a data point that differs significantly from other observations. Okay, an outlier may be due to variability in the measurement, or it may indicate experimental error. Okay, there can be variance. There can be cases where the particular data will not follow the pattern. That is completely fine, but the probability of that happening is very, very less. Okay, so here that those are called as outliers, and they have to be excluded from the data set. You have to remove them from the data set, because what will happen, the machine will start thinking that okay, this is also a possibility, and the machine will take that into consideration too. Okay, see, an outlier can cause, last point, an outlier can cause serious problems in statistical analysis. Okay, so that is what outliers means. Okay, generally what we do, okay, whenever we are working on outliers, so basically we use the IQR value. I told you, remember class, IQR value, inter quartile range, inter quartile range. Okay, mathematically IQR is defined as Q3, whatever Q3 value is, Q3 minus Q1. Okay, we get IQR. Okay, then what we do basically to calculate the outliers, how do we do that? We will basically take max, we basically calculate the max IQR, calculate the max IQR. Okay, and max IQR is basically equal to all the data greater than, max IQR is calculated like how, Q3 plus 1.5 times multiplied by IQR. Similarly, we take the mean IQR also. That is your Q1 minus 1.5 multiplied by IQR. Okay, so this is your, okay, max and min, and all the, see, outliers are basically, outliers are greater than max IQR, and outliers are greater than all data. Basically, outliers is equal to data which is greater than max IQR or data less than mean IQR. All the values which are basically more than max IQR. Suppose I am calculating, let's say there is some data, okay, and we are calculating the max IQR. Okay, so in that case, suppose your IQR value comes out to be like in this age wala case, okay, your x IQR value comes out to be somewhere around maybe, let's say 5. Let's say 5 is your or maybe 4 or maybe 3, let's say. Okay, that is your IQR value. Let's talk about Q3. Q3 is maybe, I'm assuming class. For example, this will completely this is an example. Example only. Let's say Q3 is your how much? Q3 is, we are taking the range of 17, right? 17 to 22. Let's say this is your 18 or maybe 19. No, this is the upper range, na? So 21. Okay, and Q1 is, let's say, is equal to 19. Now you will calculate the IQR. IQR is equal to Q3 minus Q1. Q3 minus Q1, that is equal to 21 minus 19 equal to 2. That is your IQR value. Plus max you will calculate. Max is equal to, you will calculate Q3, that means 21 plus 1.5 into 2. That is equal to how much? 1.5 into 2 is how much? Your 2. That is your 3. Okay, that is 3, and 3 plus 21, that is your 24. And mean is equal to 19 minus 1.5 into 2. That is your 19 minus 3, that is 16. So class, here outliers will be what? Outliers will be all the values above 24 and below 16. Outliers will be all the values above 24 and below 16. So this is how we will calculate the outliers. Okay. So now let's continue. Let's continue now. Okay. Box plot we will talk about. This plot helps us to analyze two columns, categorical versus continuous data. We can also plot a single column that will help us to identify the outliers. Outliers. Okay. So how do we do this, class? How do we do this? We will simply write SNS dot box plot. Okay. Now SNS dot box plot, right? And let's take the, see, let us Tina. So let's try to find out the outliers in age. Okay. In the age column, separated T of age. Okay. So here it has when we are plotting single column, so it is giving me T age. So these are your outliers. These are your outliers. Basically, let's see, the majority of the people on the ship are in the age range of 20 to 38. You can see they're in the age range of 20 to 38. Majority of the people. Okay. The median value is how much? This single line that you can see here in between, this is your median value. Okay, this Q2. Q2 is basically your median value. Okay. So Q2 is somewhere around, I guess, 28, right? Okay. Now, this lines that you can see on the 0 and at somewhere around 64. Okay, these lines are basically your min IQR and max IQR. And all the values below it or above it, there are no values below it. Okay, there are no values below 0. Okay, but there are some values above 60. So all of them will be taken as outliers, and we have to remove them from the data set. We have to remove them from the data set. See, there are multiple ways of calculating the outliers. Okay, again, depending on the problem to problem, application to application. Okay, the outlier formula may differ. Okay, see, obviously this is like, it is totally up to us, right? Which values we want to take into consideration as outliers. It is totally up to us, because as humans we have to decide. We have to put our common sense. We have to decide that okay, this data is basically going out of pattern. That is something we have to decide. Okay, here the general formula, that is your this formula that I have mentioned here, Q3 plus 1.5 into I cure or Q1 minus 1.5 into I cure. This formula is basically just for analytical purpose. Okay, it is not a sure set formula in every case. It completely depends on the application, amount of data, what kind of, like the data is of which sector, okay, how much variance is there in the data set. Okay, if there is a very high variance, if there is a high variance, so there is a high possibility that the number of outliers will be less, because it will take, see, think about now, what is the meaning of variance? Variance means how much variation is there in the data set. So let's say if we're talking about a college and there is a lot of variation in the age of people. Okay, in some college, let's say there is a, like a lot of difference is there in the age of people. So in that case we will not consider outliers at all. This might also happen. Okay, because there is a possibility that all of them, even the student of 25 years of age, that is also coming into pattern for that particular college or for that particular type of college. Suppose I am talking about medical colleges. Okay, so in MBBS we know that it is 5 years of, right? 5 years are there in medical. Okay, and sometimes students also take a gap. Okay, they drop a year or two. Okay, for NEET exams and all, they drop a year or two in the starting. Okay, so we have to consider that also. So there is a possibility that a person who is studying MBBS is of the age of maybe 18 to 23, possibly, right? Or maybe 19 to 24. That is also possible. Or maybe 19 to 25, in the age range of 18 to 25. Okay, or 18 to 26 even. That is also a possibility. Okay, so we have to take all of those factors also into consideration, that okay, which sector are we talking about particularly. Okay, so this is your box plot class. Now if you plot a single column, it will look like this. Suppose you take two columns P of H, and you want to take, let's say, see, it is taking categorical versus continuous. So let's say T of H and TP class maybe. See, on the x-axis we need P class, na? So that is why I have to write P class first. Okay, so now it is telling us age about each and every class. Okay, so in the first class, this is the age group. You can see there are more people in the age range of 27 to 50 in the first class. In the second class, the people are more in the age range of 25 to 35. Okay, and in the third class, people are more in the age range of 20 to 32. Okay, so that is how we calculate, and these are outliers. So in the second class, you can see in the first class and third class there are no outliers, but in the second, there in the first class and third class there are no lower outliers. On the lower side there are no outliers, but in the second class there are outliers both sides, upper side also, lower side also. Okay, so now see, in this case now it is basically calculating outliers separately. It is calculating outliers for P class 1, P class 2 and P class 3 completely separately from each other. That is your box plot. Now class we saw hue column also, hue argument also, sorry. So you can take hue also consideration, and right here hue is equal to, let's say we want to do it on the basis of text column maybe. Okay, we can, give me a minute class. Okay, so let's continue now. So here you can see when we are taking sex column also into consideration, so it is basically dividing them on the basis of male and females. Okay, so in the first class you can see males are basically in the age range of 30 to 50 majorly. Okay, same for all of them. It is giving us data for all of them. So class, this is your box plot. Let's continue now. Next is your violin plot. Violin plot. The violin plot is what? Basically, this plot helps us to analyze two columns, categorical versus continuous data, just like your box plot. Okay, but it basically draws a combination of box plot and KDE. See, violin plot is basically a combination of box plot and KDE. KDE is must. KDE is fixed. Okay, but box plot we can change. We can take some other plot also in place of box plot here in case of violin plot. So SNS dot violin plot. Let us take the age only for now. Let me show you with a single column only for now. P of. So now you can see this is your violin plot. Okay, in between class, in between here you can see this is the boundary that you can see here class. This is your KDE. This is your whole KDE. Okay, the endpoints. Okay, the endpoints are basically your minimum value and the maximum value. Basically according to the kernel density estimation, that is your KDE. Okay, your line, this line that you can see, this line is basically your mean IQR and max IQR. Okay, the white color dot that you can see in between, that is your median value, and at both sides that is your Q3 and Q1 class. Now if you take two columns into consideration, let's say I'm taking P class also, just like before I am showing you. You can see now it is taking basically showing us violins according to the P class. Okay class, so that is your KD. If you want to include hue, just like we did here, you can do that too. You can also be included. Now one more thing that is here, one more the important thing that is here on in violin plot class, that is your inner argument. See, by default the value of inner is box. By default the value of inner is box. Okay, but you can take something else also into consideration. See, inner can be a box, quartile, point, stick, or none. Okay, it can be these five values. So what is the meaning of this class? What is the meaning of this? This is your inner. Okay. So now if I take this code class, and if I write here inner is equal to none, you can see in the inside it is showing nothing. Right now here it is taking box plot inside, but now it is taking nothing inside, none. Okay, outside obviously remember outside your outer plot will be your KDE plot always. Okay, but the inner plot you can decide by default it will take box plot, but you can decide something else also. Okay, suppose you say that okay I want point plot maybe. So you can mention a point. You can see it is point plot inside. Point plot is basically a scatter plot, same thing. Okay, you can take stick plot also. Stick and scatter are also same thing. Somewhat in the stick plot, it shows you the whole distribution also in the whole range. Okay, then your quartile basically gives you Q1, Q2, and Q3. Box plot gives you Q1, Q2, Q3, min IQR, max IQR, and outliers. Okay, in the box plot. Okay, but in the quartile plot, you will get only quartiles. You can see only quartiles. Q1, Q2, and Q3. That's it. Okay, class. So that is your volume plot. Let's continue. Next is your strip plot. Strip plot. How does it work? Okay, this is your strip plot. This plot helps us to analyze two columns, categorical versus continuous. It draws a scatter plot. So now suppose if I take this into consideration. I will just mention strip plot here. Here you can see class, this is your strip plot. That's it. So see, it is saying that draw the scatter plot. So it is giving you scatter plot for age. Okay. You can include hue also if you want to here. Hue can be included. No problem in that. Okay. Now there is an argument called as jitter here. There is an argument called as jitter. Let me show that. Jitter equal to false. See, when you write jitter equal to false, you will get this data. By default, jitter equal to true. Okay, jitter equal to false, then it will overlap one of them. Okay, now here we are not able to see the concentration actually. Here we are able to see the concentration at least. Okay, where there are more dots. Okay, at that place there is more concentration of people in that age range. Okay, but here in this case we are not able to see the concentration perfectly. Okay, class. So that is your strip plot. Let's continue now. Next is class. After this, next is your swarm plot. Swarm plot. So this also you can see swarm plot also basically works in the same manner. Okay, here it is basically giving us the distribution. Okay, this is basically giving us the distribution of data points. So you can see the data points are considered more in between. Okay, if you see swarm plot, SNS dot swarm draw categorical scatter plot with non overlapping points. This function is similar to function strip plot, but the points are adjusted, okay, only along the categorical axis so that they don't overlap. This gives a better representation of the distribution of values, but it does not scale well to large number of observations. This style of plot is also sometimes called as a bee swarm. Okay, this is also called as bee swarm because it looks like swarm of bees. Okay, class. So that is your swarm plot. Let's continue now. Next is your pair plot. Pair plot. What it is? SNS dot pair plot. Plot pairwise relationships in a dataset. By default, this function will create a grid of axes such that each numeric variable in data will be shared across the y-axis across a single row. Achha, give me a minute, class. Okay, so let's continue class. Okay, so what it is saying, by default this function will create a grid of axes such that each numeric variable in data will be shared across the y-axis through a single row and the x-axis through a single column. See, you will understand pair plot. Let me show you. SNS dot pair plot. Quickly. First of all, it will take all the numerical columns. It will take some time. It is a big plot. See, this is a pair plot. Okay, it is showing us relationship between multiple columns. See, relation between survived column and the alone column. Relationship between P class column and alone column. Relation between age and alone. SIBSP and alone. Similarly, relationship between fair and survived. Relationship between P class and fair. Okay, so you can see it is plotting up a lot of plots here. See, the diagonal one is basically the same thing. Alone and alone. Plot between alone and alone like this. Plot between adult male. Plot between your fair and fair. Plot between parch and parch. SABSP, SIBSP. Age. This is your P class, survived and survived. Okay, so we can basically ignore all the diagonal plots. We just need to focus on the lower half or the upper half diagonally. Lower half or upper half diagonally, that we have to care about. Okay, so this is class. This is a pair plot. Basically, what happens whenever we are doing analysis? Okay, so pair plot and heat map. These two plots are basically one of the mostly, like one of the plots that we plot right in the starting itself. Right in the starting itself, whenever we are working on analysis. So we first plot the heat map to understand the relations. Okay, and then we will plot the pair plot directly to see that how multiple columns are affecting each other in the whole data set. Okay, so class, that is your data visualization using Python, using Cbol. Okay, so after this class, I have to start a new topic. Okay, but I guess, see, there is no point if I start a new topic right now. Okay, it is already 7:15. So what we can do, class, today, we'll work on some questions. Okay, so right now what I'm going to do, okay, I'm going to share some questions. I'm going to share some questions with all of you over chat. Okay, on the chat I will post some questions, and all of you have to work on those questions right now in the class itself. Okay, just give me a minute. I have to open. Let me open the questions. Okay, class. So I'm sharing first question here on chat. Okay, WP means write a program. So write a program to read content from one file. You have a TXT file with you. Okay, and in that TXT file there are two paragraphs. There are two paragraphs present. Okay, and those two paragraphs are separated by this dash 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 in between. First paragraph, then dash dash dash, then second paragraph. This is how the file is. Now what you have to do, you have to create the contents from this file, and you have to save those two paragraphs into two separate files, completely two separate files. Work on this question now, class. Very simple question. File handling we have already covered. Okay, so based on that, you have to work on this. Class, if you have any doubt, please feel free to ask. Okay, class. So make sure that okay, I have shared 3 questions here on the chat. Okay, I have also mentioned them on the file also in the Jupyter notebook. So make sure you complete all these questions by the next class. At least these 3 questions, all of you need to cover. Okay. So yeah, that is all for today then. Okay, everyone.